Hi everyone, good morning. I'm going to present today on facade integrated mechanical systems and how they can be very effective for building retrofits. A couple of objectives that we're trying to target, the current challenges with aging multifamily housing and why traditional retrofit methods fall short, the components and functionality of facade integrated mechanical systems, the envelope, the hydronic piping that runs in it, and the ventilation integration. A quick acknowledgement to David Goldstein, who's been leading the charge in implementing the system. Coming to the outline and agenda, why do we need to retrofit? Then we will talk about what the traditional methods are, as well as the limitations, what a facade integrated mechanical system even is, and then we'll get deeper into a pilot project that's going to implement facade integrated mechanical systems, the pre-construction activities that we're carrying out, as well as the challenges and solutions that we're facing. And then we'll conclude with a quick summary. So why retrofit? Today there are lots and lots of multi-family buildings that are existing, but they're also pretty outdated. They have leaky, uninsulated envelopes. They have outdated HVAC systems with gas-fired boilers. They lack central cooling for the most part. They don't have any ventilation. The lack of ventilation also creates poor indoor air quality and comfort, which I think she just addressed as well. And they're also very expensive to operate and maintain. The facade maintenance is pretty costly, pretty time-consuming. So it's not a great scenario we're in right now. And then coming to traditional methods, a lot of them are piecemeal. A lot of times, buildings are retrofitted with the roof being upgraded, or there's an overclad done where the insulation is updated for the walls, or windows are replaced. A lot of these solutions are often invasive and require tenant relocation. This is not always feasible. Like in a city like New York, you can see in the image there, there's lots and lots of people and lots of buildings, but we don't have any spare locations to put the tenants in these buildings when we are working on them. So we need them to be in place. The traditional retrofit methods are also expensive with very poor ROI. So unless there's a policy, it's very hard for a building owner to decide to allocate resources, money, to taking any action. In terms of the HVAC side, there are two kinds of typical systems. It's either unitary or central. Unitary systems have the benefit of being very quick to be installed, but they often are less efficient. They lack ventilation. Also, they require frequent access to each apartment for maintenance. Central systems are more modern in the sense that they're more efficient, but then they're also very highly disruptive. You would often need to make openings in buildings. You have to run new ductwork, piping. You have to get rid of all the tenants from the building while you're working on it. And overall, the project timelines are much longer. So coming to what facade integrated mechanical systems are, they help implement cutting-edge central HVAC systems. These existing buildings, which right now have no ventilation, you can provide ventilation. You can provide thermal comfort to them. They also help. They're much more easier to operate and maintain just because of the centralized nature of modern HVAC systems. They also help reduce HVAC emissions by up to 90%. There's a whole new overclad which also helps revitalize the building's appearance. And all of this can be done with the tenant in place within the apartments. So what exactly are the key components? At the central plant, there are two main components. It's the heat pump, which can be air-sourced, water-sourced, ground-sourced, depending on the particular site. And that basically serves chill water or hot water to the apartments. On the other end, there's the energy recovery unit, which would recover energy from the kitchens and the bathrooms, while also providing fresh, conditioned, filtered, and dehumidified air to each of the apartments. Now, both of these components can either be on the roof, where they typically end up, or they could be in a mechanical room if there is one already, or they could be on the ground. They then serve ductwork and piping that is run outside the building in a cavity that is formed between the existing wall and the new facade panel. They then connect to the facade integrated terminal unit, which basically is a fan coil that will help provide the heating, cooling, as well as ventilation to that particular apartment. Every occupiable space can get its own facade integrated terminal unit, essentially allowing for individual control. The facade integrated terminal unit is also a sensible only unit in the sense that there is no condensate coming out. There's all the latent load is taken care of by the dry and dehumidified ventilation in. So the pilot project where this is being implemented is in Syracuse, New York. It's a 7-story building, 52 apartments, completely occupied. It's about 40,000 square feet. Right now, in terms of HVAC, the only thing it has is gas-fired boilers that are basically actually in an adjacent building and has piping running to this building to serve radiators that are placed underneath the windows. There's no active cooling. There's no active ventilation, at least directly to the apartments. Some tenants who can afford it have window units that have been put, but for the most part, as you can see in the image, most of them don't have any form of cooling, and with rising temperatures, that's starting to become a big issue. In terms of ventilation, there's only corridor ventilation, which is basically a code minimum supply to the corridors that's just pressurizing them. So this is, I'm the colder guy in that photo, but essentially this photo is from last Jan. This is a thermal image of the building. You can see another issue with existing HVAC systems where basically the boilers just pump heat into the apartments. There's very little control. Some of the apartments basically open their windows up just to let the heat out because it's so aggressively hot. So not only is it wasting energy, you're also burning a lot of carbon, and it's just basically getting blown out into the air. So in terms of the upgrade here, we're going to have a facade upgrade, essentially, which is going to upgrade the facade insulation to our 22 levels, a triple pane windows that are going to be applied, 0.15 U value and 0.18 SHGC. Like I mentioned earlier, there's going to be a cavity, a 6-inch cavity where the ducts, piping, everything is going to run to the units, to the apartments. First, the facade integrated terminal units, which will provide the cooling and the heating to each individual occupiable space. In terms of the central plant, we'll have 8 total central heat pumps, 2 for each wing, basically providing partial redundancy. So in case one heat pump fails, there's at least another heat pump for each wing. But also, this helps divide the wings. So if in case there's an issue on one wing, there's no problem for the other 3 wings. And similarly, with the energy recovery units, we have 4 of them, 1 per wing, allowing for some sort of redundancy within the building. So we've done a lot of pre-construction work already. We have developed a lot of design drawings in terms of ironing out the particular existing conditions for the building, that tight inside corners, trying to maintain the existing window sizes. We don't want to reduce light getting into the apartments. We also don't want to reduce the amount of the view that the tenants get. For them, it's hard to accept any kind of change. So we want to try to keep as much as possible the same. In terms of a mock-up, we've actually done a construction mock-up. I personally had never seen anything like this done before, but we built a wall that replicates the existing conditions on our general contractor's shop floor, where basically the wall was exactly what we would have with the existing building, the window sizes, the tight inside corners, and then we had the mechanical subs, the electrical subs, and the general contractor basically installed the system on this wall as if it was in an existing, as if it was on the main project. It really helped iron out the details in terms of who controlled what scope, what were the logistics of the project, procurement, etc. In terms of, there was another mock-up we did, but that was more in terms specifically for facade panels, where a performance mock-up was conducted, basically to test the thermal performance of the panels, but also the wind integrity, the structural integrity of the panels. An energy model has been run. We are saving about 82% in terms of HVAC energy consumption, which is quite drastic, especially given the fact that we're adding ventilation to each of these apartments. There's no ventilation right now, like I mentioned. So they're all going to get ventilation. They're all getting cooling, which they didn't have before. But we're also reducing the energy consumption by 80% just because we're not pumping heat all the time and we don't have the leaky envelope that the building currently suffers from. Overall, the investment is going to net 8.9 million NOI over 30 years. It's a higher upfront cost, but essentially you save a lot through facade maintenance, HVAC maintenance, as well as the energy consumption and utility bills. So we have had a lot of challenges and solutions. I've tried to summarize 6 of them here, but essentially we've first had the ambitious effort of having only 5.5 inches for the cavity. The contractors managed to fit the ductwork and the piping in that space, but some things were a little jammed a little more tight than they should have been. So we have now changed the cavity depth to 6 inches, which is plenty, and it helps with accessing all the ductwork, piping, valves, everything that's running inside that cavity. In terms of the anchors, they were very labor intensive previously. One of the key issues with overclad systems is it's very existing condition dependent. Most of the walls are never completely straight. Some are bending outwards, some are bending inwards. So there's a lot of site variability that happens. And to minimize any rework on site, we had to really design these anchors so that they could be adapted on site as and when needed. In terms of piping, we were initially looking to use push-to-connect hoses. They would have basically made the system a lot more efficient, but they're also pretty new in terms of a kind of fitting. And given that everything else that we're doing is also very new, the mechanical contractor suggested that maybe we hold this off for the next project that we do. So for now, we're going to stick to more traditional threaded union connections, which again have been tested. The contractor was very easily be able to access the facade integrated terminal unit on site and make the connections, disconnect them, make sure that they were pretty straightforward to maintain, and also the access doors were located pretty conveniently for their use. Another issue with that 5.5-inch cavity that I just mentioned was the conduits were not fitting. There's low voltage power that's running and serving these facade integrated terminal units, and essentially the 1-inch conduit is more than 1 inch technically after the outside diameter is added on, and that would just not fit. So we had to run multiple 3/4-inch conduits, and which made everything more complex. We had to coordinate more, we had to upgrade the shop drawings more, and more material wastage as well. Now that we have the 6-inch cavity, running the 1-inch conduit is much more straightforward. In terms of the facade panel itself, the performance mock-up had issues with having the continuous air, water, and thermal barrier. We had to work a lot in terms of developing the right gasket and flashing details, making sure that we're able to have the air tightness we need. This whole system relies on making sure that the new overclad is airtight, watertight, there is no leakage. So there was a lot of joint profiles that were developed and tested to make sure that not only is it airtight, watertight, but it's also very easy to install on site. So in summary, multifamily building stock is aging, as a lot of us have already spoken about today. There is a need for retrofit solutions that are cost-effective, scalable, as well as tenant-centered. Facade integrated mechanical systems can deliver substantial energy and carbon reductions, and also help ensure thermal comfort and resilience is maintained. Pilot projects are also important. They serve as test beds for essentially resolving any technical uncertainties. We've done a lot of development because of our pilot project. I don't know how far we would have gotten if we were just trying to do it through simulations. And then finally, facade integrated mechanical systems provide a scalable pathway to decarbonize millions of underperforming buildings. Thank you.
Thank you for your presentation. Can you speak a little bit more to the response of the tenants to the pilot project?
Yeah, sure. That's a great question. Resident engagement, I didn't cover that too much in this presentation, but that was a pretty critical part of the work we've done till date. The tenants were surprisingly very happy to be involved. First of all, they were included from the start of the design process. We wanted to know, to the extent that we wanted them to decide the color of the facade, where do they want to have the diffuser for the facade terminal unit, essentially where the grill sits, the depth of the cavity. One of the reasons we wanted to have 5.5 inches initially was because we thought they wouldn't like that additional window sill that they will now have. But turns out they wanted that space. They were like, that's fine. It almost gives them more space in their house, or a perception of more space. There was other concerns about their views being disturbed, like in the sense of windows being slightly shifted. It's not exactly the same. We basically, based on the conversation, they were very excited to have a new system in the building. Like I said, right now there's no ventilation. A lot of even the corridor ventilation, though it's running, it's probably not running at full speed. The filter is probably clogged. It's like really, so, and their cooling is a big issue. They really wanted a unit that could give them cooling, which not all of them can afford at the moment. So this gives them a chance at also having cooling as well as a better airtight envelope. So they were very they were very happy to have this new system on their building, which we were pleasantly surprised by.
Thank you, Akshay, for this wonderful presentation.
Yeah.
This is totally new concept to me. Just only surprised to this about this how this maintenance will be done. Say in case of any problem in the outside facade unit, then for a high-rise building, say like 7th floor you told, so whether has to be maintained from outside or it can be maintained inside from the home.
Right. Another awesome question. So the whole system actually, at least from my aspect, I focus mainly on the HVAC, though I kind of understand the facade as well. But the whole system was designed around having maintenance within the apartment. So the facade integrated terminal unit is designed in such a way that it's just, you can just pick up the sill. The unit is right behind it. There's only a filter there that's really being maintained. All the compressor work, all the main components are either on the roof. So the energy recovery unit, where the main compressor is, the energy wheel is, the core is, the heat pumps, all of them are not in the apartments. It's very easy to actually maintain the central plant like you would in any new modern building. In terms of the facade maintenance, it gets even easier. Now you have a whole panelized system on your building, which is a lot more easier to maintain. And that's basically a new outer shell for the building. So it almost makes it a lot better and easier to maintain rather than trying to go brick by brick and making sure that there's no asbestos behind that brick and things like that as you're treating each component of the envelope.
Hi. Maybe I missed it, but is the installation complete? Is it in service? Is the installation on the building complete?
Oh, no, it's not installed yet. Right now, this has all been pre-construction activities. The project is not completed, but it would be wrapping the entire building with insulation, yes.
Is there a timeline for that, for the actual installation?
The installation right now is on hold because of budget cuts, but hopefully we should get it going soon and we'll have an updated timeline based on the funding.
Thank you.
Yeah. Awesome. Thank you.